Cause and effect feel obvious. You flip a switch, the light turns on. You let go of a cup, it falls. One thing happens, then another happens because of it. That order feels so deeply built into reality that questioning it sounds absurd. Of course, causes come before effects. What else could possibly make sense? But that confidence is borrowed. It comes from everyday experience, not from the structure of the universe. And Richard Feynman warned again and again that when you mistake everyday experience for fundamental truth, physics will quietly pull the floor out from under you. Think about what you really mean by cause and effect. You imagine a chain. Event A happens, then event B happens as a result. Time flows forward, carrying causation with it. The arrow of time and the arrow of causality seem inseparable. That feels so natural that it's hard to imagine one without the other. But physics doesn't start with cause and effect. It starts with equations. And the equations do not care which way time points. Take the laws of motion, run them forward, they work. Run them backward, they still work. Same with electromagnetism. Same with gravity, same with quantum mechanics at its most basic level. The fundamental rules of physics are almost entirely time-symmetric. They do not say which event causes which. They only describe relationships. That should bother you, because if the laws don't distinguish past from future, then cause and effect are not written into the foundations of reality. There's something else, something emergent. Feynman loved to point this out casually, almost mischievously. He would say things like, the equations don't care which way time goes, and then move on, as if he hadn't just undermined one of the deepest assumptions people carry about the world. Let's slow down and see why this matters. Imagine a film of two billiard balls colliding. One ball rolls in, hits the other, and they scatter. You immediately say the first ball caused the second to move. But now imagine playing the film backward. The scattered balls roll together, collide, and one ball rolls away. The backward version obeys the same laws of physics. There is nothing in the motion itself that tells you which direction is the real one. So why do you insist that one version is cause and the other is effect? Because of memory, because of entropy, because of context, not because of physics. This is where intuition quietly fails. In everyday life, causes precede effects because entropy increases. Systems move from less probable states to more probable ones. Eggs break, they don't unbreak. Smoke spreads, it doesn't gather itself back into a cigarette. These processes give time a direction, and causality rides on that direction. But that direction is not fundamental. It's statistical. Feynman emphasized that the arrow of time comes from the boundary conditions of the universe, not from the laws themselves. The universe started in a very special, very ordered state. From there, disorder increases. That increase is what gives us memory records and the feeling that the past is fixed while the future is open. Cause and effect piggyback on that asymmetry. Now think about this carefully. If causality depends on entropy, and entropy depends on the universe's initial conditions, then cause and effect are not basic ingredients of reality. They are consequences. That alone should make you uneasy. But it gets worse. In relativity, the idea of a universal before and after collapses. Different observers moving relative to one another disagree about the order of events that are far apart. One observer says event A happened first. Another says event B happened first. Neither is wrong. If cause and effect were absolute, this would be impossible. What saves causality in relativity is not time ordering, but the speed of light. Only events that can influence each other are constrained to have the same order for all observers. Outside that range, the notional, cause becomes ambiguous. So causation is not about time. It's about connectivity. Feynman liked to say that physics doesn't tell you why things happen, only how they are related. That distinction is subtle, but devastating. Consider a radioactive atom. It sits there, unchanged, and then suddenly decays. You ask, what caused it to decay at that moment? The honest answer is nothing. There is no hidden trigger, no ticking mechanism waiting to fire. The decay is genuinely random within the constraints of probability. People hate this. They try to smuggle causality back in. Maybe there's a variable we don't know. Maybe it's deterministic underneath. But experiment after experiment has failed to reveal any such mechanism. The decay has no cause in the classical sense. It is an allowed event, not a forced one. And yet after it happens, it leaves effects. Energy is released. Particles are emitted. Detectors click. So effect without cause. Not exactly. The deeper lesson is that causation is not a fundamental relation. It's a story we tell after the fact. This becomes unavoidable in quantum mechanics. In quantum theory, you don't predict what will happen. You predict probabilities. You don't say, this event will cause that event. You say, given this setup, these outcomes have these probabilities. The theory works perfectly. It predicts experimental results to absurd precision. But the causal narrative is gone. Feynman was blunt about this. He said that if you try to force quantum mechanics into a classical cause and effect picture, you will get confused. The theory does not describe processes unfolding step by step. It describes correlations between observations. Think about the famous double-slit experiment. A particle goes through a barrier with two slits and lands on a screen. You ask which slit it went through. The experiment refuses to answer. If you insist on asking, the pattern changes. The act of measurement alters the outcome. What caused the particle to land where it did? The question assumes a trajectory and a chain of events that simply do not exist. All you can say is that certain outcomes are correlated with certain setups. The universe gives you relationships, not narratives. This is where people start reaching for philosophy. But Feynman didn't. He stayed with the physics. He pointed out that even in classical physics, causation is not as clean as people think. Newton's laws are differential equations. They relate positions, velocities, and forces at the same time. They do not specify which variable is the cause and which is the effect. You can rearrange the equations however you like. Force causes acceleration, people say. But acceleration also determines force. It's the same equation. Cause and effect are assignments you make, not features the equation insists on. So why does cause and effect feel so real? Because you are a system embedded in time with memory. Your brain records past states and uses them to predict future ones. That process creates a direction. It labels earlier records as causes and later records as effects. But the labeling happens inside you, not in the equation. Feynman warned that this confusion runs deep. We think causality is out there in the world, when it is partly a feature of how we experience the world. Now consider something even more unsettling. In quantum field theory, particles can be created and destroyed. Virtual particles appear and disappear. Effects can seem to occur before causes as long as no information is transmitted faster than light. The math allows it. The theory remains consistent. This does not violate causality, because causality in physics is not about temporal order. It's about consistency, about preventing contradictions, about making sure information cannot be used to send messages into the past. The universe is not protecting cause and effect. It is protecting logic. That's a very different thing. Feynman explained this casually, almost offhandedly, which is what makes it disturbing. He didn't frame it as a crisis. He framed it as a clarification. The problem, he suggested, is not that physics is weird. The problem is that we ask the wrong question. We ask, what caused this? When the theory answers, here are the conditions under which this is likely, we ask for stories. The universe gives us statistics. Now think about your own actions. You decide to move your hand. You feel like the decision caused the motion. But inside your brain, billions of neurons fire according to physical laws. Signals propagate. Muscles contract. At what point does cause enter? You can trace a chain of physical interactions. But calling one of them the cause is a choice. A useful one, but a choice nonetheless. This doesn't mean causality is useless. It means it's not fundamental. Feynman was very clear about this distinction. Physics does not deny cause and effect at the human scale. It explains why it works there. high entropy, stable records, macroscopic irreversibility. In that regime, causality is an excellent approximation. But mistaking an approximation for a law of nature is a mistake. Once you see this, time, causality, and determinism all loosen their grip. The universe stops looking like a machine that cranks effects out of causes and starts looking like a structure of allowed correlations. Events don't happen because they are pushed by the past. They happen because they are consistent with the rules. That is a very different worldview. It also explains why physics can be so predictive without being narrative. The equations don't tell a story. They define a space of possibilities. Given certain constraints, only certain outcomes are allowed. Within that space, probabilities assign weights. Causality emerges as a shorthand way to talk about these patterns when entropy gives us a direction to lean on. Feynman warned that if you insist on deeper why questions, physics will eventually say, there is no why. There is only how. That answer frustrates people. It feels incomplete, but it's honest. And here's the quiet punchline. The universe works perfectly well without cause and effect as a fundamental principle. Everything still happens. Everything is still consistent. Everything is still predictable within limits. Cause and effect are not driving the universe forward. They are how creatures like us make sense of it after the fact. The original question, what causes what, is not wrong, but it is incomplete. It assumes that reality is built like a chain. Physics suggests it is built like a web. Once you see that, the illusion becomes clear. Cause and effect feel inevitable because they are how memory-bearing systems embedded in an entropic universe organize experience. They are not etched into space-time itself. Feynman explained this casually, almost gently, but the implication is severe. The universe does not run on reasons. It runs on rules. And rules do not care about the stories we tell to make ourselves comfortable. Understanding that doesn't make the world less meaningful. It makes it more precise. It shows you where intuition applies and where it doesn't. Cause and effect are real enough to live by, but they are not deep enough to build the universe on. And that distinction is the kind of thing Feynman tried to warn us about, knowing full well that most people would nod, smile, and then go right back to thinking the way they always had.